Okay, let's teach this car to self-drive. But first, we need to create this game. Let's get started. We will do it in relatively easy to learn programming language called Python, and in particular something called Pygame 0, which is very basic programming interface for creating games. A typical game loop looks something like this. Until game ends, we loop through input processing, updating internal game parameters and rendering them on screen. Pygame 0 has two functions that fulfill these tasks, called draw and update. Draw function is called by Pygame 0 when it needs to redraw your game window, whereas update function is called by Pygame 0 repeatedly 60 times a second. And this is where we include our game logic. Now that we have some idea about Pygame 0, let's create a race car game. Please note that all necessary images needed to create this game, for example, an image of a car, an image of a barrier, should be stored in a folder named images parallel to file containing game code. Let's take a look at the code. First, we define two variables called height and width that define the size of our gaming window. Then, we have speed variable which determines the speed at which barriers approach our actor. After that, we set actor's initial position on our gaming window. Following that, we have two list variables that store location of left and right barriers. Track count variable keeps count of barriers crossed by our car without colliding with them. Then, we have three variables defining track starting location, its width, and a variable that controls location of next barriers. For example, if track direction is set to false, next barriers are placed to right of current barriers, and other way around. Finally, game status variable indicates if game is currently in progress or completed successfully, which is crossing 200 barriers in our case, or resulted in collision with the barrier. Next, we have draw function that populates game screen with needed characters at appropriate locations. This function also draws red flag on screen if you hit a barrier and a checkered flag if you cross 200 barriers. Following that, we have update function that reads in user inputs and updates car's location by 2 pixels to left or right. Next, we have make track function that adds in new barriers, and following that, we have update track function that sets variable to randomize variable location and also detects collision with barriers and set game status to game over in case of collision. Let's give credit to original creator of this game, who is Mr. Mark Vanstone. Before we get to the next segment, have a tea, coffee, whatever you like, download the code and try playing this game on your machine. Okay, now you and I know how to play this game, but does the computer know how to play this game on its own? At this moment, definitely not. We can teach it to play this game using something called reinforcement learning. Let's look at some terminology from reinforcement learning world. First, we have agent. It is the thing that interacts with the environment, and it does it using actions. That is, in our case, actions can be either moving left, right, or not moving at all. On taking any action, agent moves from one state in environment to another state. On moving to a next state, we give agent a reward. For example, if next state leads to successfully crossing barrier, we give agent a reward of +1. If next state leads to collision with barrier, we penalize agent with reward of -300. But how does an agent decide on which action should it take in its current state? Answer to this question is something called action value function or Q function. This function tells agent the value of taking an action in any given state, where value of a state represents measure of possible future rewards. Let me say that again. This function tells agent the value of taking an action in any given state, where value of a state represents measure of possible future rewards. So the job of our agent is to take an action with maximum value, and it will ride the track without any collision. But there is another problem. Agent doesn't know action value function of an environment when it interacts with it at first. So we use an iterative algorithm where we initialize action value function randomly, and then as we play episodes of our game, we update action value function such that it converges to true action value function of this environment. Let's take a look at this algorithm in code. First, we obtain the current state of our agent in the environment. For our game, it's distance from few barriers in front. We sample an action based on Q function. We execute that action to get reward and next state. Based on reward obtained, we update our Q function, and this goes on and on and on forever. On running this code for about 20 hours, we get quite a decent driver.